Let's use our comparison test to determine if the following series converges or diverges, the sum of the natural log of n over n. Now we know that as n goes to infinity, the natural log of n increases, so it's certainly bigger than 1 for n bigger than or equal to e. So the natural log of 1 is 0, so certainly 0 over 1 is not bigger than 1 over 1. But at some point, the natural log of n gets greater than 1. In fact, for any number n bigger than or equal to e, that is from 3 onwards, then the natural log of n over n is going to be bigger than 1 over n. And we know that the sum of 1 over n diverges, that's the harmonic series. And we know that the terms of this given series are positive, and also they're bigger than 1 over n for n bigger than 3. So the sum from 3 to infinity of 1 over n diverges, and therefore the sum from 3 to infinity of the natural log of n over n diverges. And now, since the first few terms don't really influence whether a series converges or diverges, we can say that the sum from 1 to infinity of the natural log of n over n also diverges. Here's another interesting series, the sum from 1 to infinity of 1 over n factorial. This n factorial grows very quickly as n grows, so I would expect that the terms of this series are getting very, very small very quickly. So most likely it converges, but I want to use the comparison test to figure this out. So I need a series to compare this to, which converges, and the terms of this series are less than or equal to the series I'm using for comparison. Well, certainly the terms of this series are all positive. There's nothing to worry about there. And we have n factorial as n times n minus 1 times n minus 2, and I keep multiplying until I get to 1. And notice that for n large enough, n is bigger than 2, n minus 1 is bigger than 2, etc., etc. 2 is bigger than or equal to 2, and 1 is equal to 1. So n times n minus 1 times n minus 2, etc., etc., is bigger than 2 to the n minus 1. n factorial is bigger than 2 to the n minus 1. And therefore, 1 over n factorial is less than 1 over 2 to the n minus 1. So now you can see where I'm going with this. I'm going to compare the series, the sum of 1 over n factorial, to the sum of 1 over 2 to the n minus 1, which is a geometric series with r equal to 1/2, so I know it converges. In fact, I can even find the sum. Since the sum of 1 over 2 to the n minus 1 converges, we can conclude from the comparison test that the sum from 1 to infinity of 1 over n factorial also converges.